All right, welcome back. So last time we talked about precision, right, and accuracy. So a bit of a I suppose, to try to refresh our minds, right? So precision actually talks about how many of the data are, how many of the predictions are actual positives, right? So it's a good measure to determine the cost of false positive. So yeah, um, it's actually used when you want to be very sure of our prediction, you know. Okay, and I suppose now we are gonna talk about recall, and later on we're gonna talk about this one concept where it combines precision and recall, called the F beta score, or more commonly used as F1 score, which we will discuss later. So essentially, recall is um, what proportion of actual positives is, actual positives are correctly classified, right? Or like true results, in this case, like true results, like actual true positive from total actual positive. And as you can see right here, it is actually true positive over true positive plus false negative. Um, so recall is essentially a valid choice of evaluation metric when we want to capture as many positives as possible, right? Like for example, if we're building a system, right, to predict whether a person has cancer or not, we want to capture the disease, uh, even if you're not very sure, this is very different as opposed to precision, right, where you want to be very sure of our prediction. So yeah, okay, yeah, and in the case of COVID-19, for example, the cost associated with false negative will be extremely high if the sickness is contagious. Yeah. Okay, so um, okay, now we move on to the F beta score, or uh, as people like to call it, the F1 score, because it takes the value of 1 for the beta value. So the F1 score essentially combines precision and recall into one metric by calculating the harmonic mean between those two. So yeah, it is actually F1 score is actually a special case, right? A specific case of the more general function F beta. So simply put, it is actually how much you care about recall over precision, right? Like for example, when you put the value of beta to 1, right? So it's F1. You care equally about recall and precision, right? But when you put, let's say, the value of beta equal to 2, the recall is twice as important to us, and etc etc, right? Like for example, if you put like beta as half, that means precision is actually twice as important to us than recall. Okay, and you want to use F1 score when uh, you want to maintain the balance between um, precision and recall for the classifier, right? So yeah, a good example would be if you want to catch criminals, right? So you want to catch a person that you're very sure is a criminal, and you want to capture as many criminals as possible, right? So you will need both precision and recall, right? Precision where you want to be very sure that the person is a criminal, and recall where you want to capture as many possible criminal as possible, So yeah, this is essentially I would say the more general function, and but usually we just skip the general function and just use beta equals to 1, so it would be like f2 score equals to 2 times precision times recall over uh, beta value squared times precision plus recall. So that's pretty much it for recall and F1 score. And in the next video, we'll talk about area under the ROC curve, as well as scoring time and fitting time. I'll see you in the next video.